Hi, everyone. My name is Jacob Kaplan, and I'm a senior here at Trinity College, and I'm the 2024-25 President's Fellow for the Neuroscience Department. It's a privilege to welcome you all here to this year's President's Medal for Science and Innovation ceremony and lecture. We are delighted to host such a distinguished alumna back on campus for this special occasion. Kyla Wynn is an epidemiologist and professor of psychiatry and behavioral sciences at the University of California, San Francisco. Dr. Lewin graduated from Trinity with her bachelor's degree in neuroscience in 1998. She then completed both her master's and doctorate degrees in social epidemiology at the Harvard University School of Public Health, before serving as a postdoctoral fellow in the Robert Wood Johnson Health and Society Scholars Program and Clinical Services Research Training Program, both at the University of California, San Francisco. Dr. Lewin's primary focus of research is how adverse experiences during early childhood can influence the risk of development of psychopathology in pediatric populations. Her extensive research and publications integrate methodologies and approaches from neuroscience, epidemiology, and psychology, and include both neuroimaging and epidemiological-based studies. Dr. Lewin has served a primary role in the creation and implementation of 3 cohort studies focusing on neurodevelopmental outcomes, including the Candle and Pathway projects, as well as serving as a co-PI in a study analyzing the effects of lead exposure in Flint, Michigan on child developmental outcomes. Much of this research highlights the interplay between chemical and social factors in altering youth developmental pathways. Dr. Lewin is the recipient of many awards, including the National Institute of Mental Health K1 Career Development Award and the National Academy of Sciences Sackler Colloquia Travel Award. In just a moment, this year's recipient will deliver her keynote address, entitled Achieving Equity in Child Mental Health and Neurodevelopment, Integrating Insights from Epidemiology, Neuroscience, and Psychology. Without further delay, I am deeply honored to introduce the 2024-25 recipient of the President's Medal for Science and Innovation, Dr. Kyla Wynn, class of '98.
Thank you, Jacob. Congratulations, Jacob. It's really exciting. Thank you so much for selecting me for this incredible honor. I am so grateful for my time at Trinity. I just specifically want to thank Sarah Raskin, who was my undergraduate advisor, for wonderful mentorship then and then continued sponsorship and thinking of me for this, and also to President Joanne Berger-Sweeney for selecting me for this. I actually spontaneously tell people what a wonderful education I had here. They don't ask, I just tell them. And I really do feel like, while Trinity is so strong in the sciences, for me, I actually feel like the liberal arts side of my education is what has really helped me thrive, the interdisciplinary side. A lot of us that go into STEM, maybe we like being alone in our rooms with our computers, and maybe we don't like, expressing ourselves so much to larger audiences. And I think Trinity really gave me this well-rounded experience and helped me kind of develop skills I might not have developed otherwise. So I'm going to tell you a little bit about my trajectory and then also just a few lessons that I've learned. I don't have too much time with you, so it'll be just a smattering of things that I've done. So just to start out, I was very interested in how the mind worked from a very young age. I was really interested in psychology, but my father really wanted me to go to medical school. He was a Trinity alum and a physician. His dad was a Trinity alum and a physician. And so, there was a lot of pressure to keep that good thing going. So I was very dutiful, and I found behavioral neuroscience here at Trinity, which, at the time was a really groundbreaking program, it was kind of this wonderful balance between being interested in the mind and psychology, but also it let me meet requirements for med school. And I also, even from this time, there are some core takeaways that still influence my work. For example, really kind of the dynamic nature of brain development, particularly early in life, has really stuck with me. You see here on this graph in yellow kind of what's going on in pregnancy and then through early childhood, and basically things kind of level off at 20 and it's kind of all downhill from there. But if we think about the earlier times, these sensitive periods of a lot of change really signal opportunities for influence and influence of the environment, and that really stuck with me. And I continue to focus on kind of early life as a critical window for intervention. Oops, I'm not quite ready for that. So everything was going great, and I was, kind of going along with my major, and then actually pretty suddenly and unexpectedly, my father passed away my junior year, and that was actually quite a destabilizing event for a lot of reasons, as you can imagine. But he also was a real driver behind a lot of my academic achievements, and I was kind of adrift, and I actually coped by traveling quite a bit. I went alone to probably many places I shouldn't have gone to by myself. But even though it was a kind of unfocused time, it was a really important time because I was really exposed to just the dramatic array of developmental environments that were very different from my own, and a lot of inequities, a lot of poverty, things that really just struck me as unfair and things that I wanted to keep thinking about. And so fortunately, I did not just keep traveling the earth, which at one point was my plan. My dad's best friend in college, Dave Alberts, so also a Trinity alum, kind of swooped in and was like, you need to do something else. And so he took me into his lab, where I worked with him for quite some time. And that was where I discovered epidemiology, which really I loved it right away. And there's a number of things about epidemiology that I really liked. I loved this focus on populations. How do populations become sick or healthy? And also a focus on upstream causes of disease and a focus on prevention. This contrasted a lot with kind of the medical school kind of idea and model where somebody comes into your office, they're sick, and you need to help them get better. I really like this idea of focusing upstream. And it also was a very good fit for my interest in the social environment because a lot of those causes are upstream as well, right? They start very early in life. And so I was lucky to find a social epidemiology program at Harvard that really focused on the social determinants of health, things like socioeconomic status and race and ethnicity and education. All of these things have very, very strong associations with health. And in particular, we are very worried in social epidemiology about the challenge of the gradient, which is essentially that with every increasing level of socioeconomic status, your health essentially gets better. And this is true for children too. We see the same kind of gradient for achievement outcomes, cognitive development, physical health. And so these disparities actually really start very early in life. And importantly, the social determinants of health actually account for about 30 to 55% of health outcomes in the population, right? And so these are really big drivers of health. And just as a comparison, now we are mapping the whole genome. Genetics for the things that I study, like cognitive development or depression, they account for about 3 to 10% of the variance. So these social factors are really very important. And so given my background in behavioral neuroscience and this new kind of real interest in the social determinants of health, I kind of wanted to bring it all together, which I tried to do in my fellowship with the Robert Johnson Foundation, and kind of began to see myself as somebody that was going to investigate social disparities in brain development using human neuroimaging. That felt like kind of the nexus there. And so here I was, newly minted, very well trained, with this great idea that I thought I had. And so I went out to do that, but actually at the time, it was a pretty tumultuous time in the behavioral sciences and in neuroimaging in particular. There were a lot of really compelling papers that came out, things like this study by John Ioannidis, Why Most Published Research Findings Are False, this notion of power failure, why small sample sizes undermine the reliability of neuroscience. And this kind of led folks to worry that there is this replication crisis in psychological and behavioral sciences. And a lot of this concern had to do with the use of very small samples that were underpowered to really detect an effect, and often what would happen is you would detect kind of a spurious effect because it was unusually large, right? And so that was kind of a critical issue here. And I'll just say that it's still kind of happening. So this is a paper from 2 years ago, basically talking about how looking at brain-wide association studies, which is kind of a common method in neuroimaging, requires thousands of individuals to be very well powered. So this was a bit of a challenge to what I was thinking about doing. But as an epidemiologist and thinking a lot about populations, I did have another notion that it might not just be how many people you study, but who we were studying. And that brings me to my first lesson, which is who participates in research really matters. And it matters even for studying things like brain development. So at the time, folks were also talking about this issue that most studies in the behavioral sciences were weird. And what this meant was that these studies came from Western, educated, industrialized, rich, and democratic countries, like the US. And that wasn't necessarily kind of the experience of most people in the world. And kind of the fundamental aspect of this that's a little bit challenging is this notion of convenience sampling. And that just means that if I have a question that I want to answer, often the most typical thing that is done is you just kind of go out, in your environment, maybe near your university, and you ask people to come be in your research study. And so you end up with a very select group of people, and then you use this select group of people to maybe talk about what's going on in the United States, maybe even the world when it comes to kind of basic theories and things like that. And so, and this is something that we see specifically in the United States, where we often see a lot of studies that focus on white, higher income and higher education individuals. And we actually see this a lot in pediatric studies too. And so this makes us worry about things like generalizability, meaning who can we generalize our findings to once we're done, but also this problem of selection bias where a relationship that we see might actually not be true because there's some imbalances in our study that are leading to kind of a different association than what might be the truth. So I was interested in whether this pattern of choosing participants might impact our understanding of brain development. And so I picked a really, really simple association that I thought probably wouldn't be affected, which is this age-related difference in brain structure. And basically, this was a really popular thing to kind of look at the time. How does brain structure change with age? And we decided to ask this question by leveraging this large study that was publicly available at the time, which was actually very innovative for the time, with about 12,000 children that had been examined that were between the ages of 3 and 18. And so what we did is we compared two sets of results. We looked at the associations between age and brain structure in kind of the standard way, which is the unweighted way, and I'll explain what that means. And then we also looked at this association weighted in a manner so that the sample better reflected the US population on things like family income, parent education, and child race. And so just a little more on why we might want to weight. So here you can see that in the pink sample, they're actually a bit different than the US sample that you see here on the right. So the pink sample in general has higher levels of education, higher levels of income. And so if we did a typical study unweighted, we would just put all of those folks into the model and they would contribute equally. But what weighting does is it actually gives folks weights that are, that it weights folks who are underrepresented in your sample a little bit more, and folks that are overrepresented, it weights them a little bit less. And so it looks a little bit more like what you see down here on the bottom with these different size circles indicating kind of a distribution that ends up getting us closer to the United States population. And so we compared these two sets of results, just looking at something very simple, the association between age and brain structure in this study. And we actually found some pretty big differences. So the blue line is the unweighted model, and the red line is the weighted model. So you can see that these shapes are pretty different. This is just for total cortical surface area and total subcortical volume. But we also looked at difference in kind of peak development, which is another metric folks like to use. And we saw big differences there as well. And so while our goal wasn't necessarily to kind of come up with the perfect relationship between age and brain structure. There's probably larger longitudinal studies are better than that. We do feel like we demonstrated a few key things. And that is that when we even use these large convenience samples, they still may not do a good job of representing or reflecting US children. These practices may really impact our study results. Our findings then may not generalize to some children. And this may further contribute to the replication crisis, right? So if we're constantly studying small samples of people that differ in subtle ways, that may be another reason why we're not seeing things that replicate. So who participates in research matters because the brain is impacted by experience. And so if we don't represent the diversity of experiences, we're not representing the brain. So then this was me. And if you see like some stress or anxiety in this picture, I was feeling all of that. I really wasn't really sure what to do next. It didn't really seem like neuroimaging was quite ready for what I wanted to do because I wanted to work with these large samples and certainly very diverse populations. And so I decided to go back to my epidemiology roots and kind of bring some of this neuroscience and developmental insight with me and kind of try to understand inequities in early learning environments and how they lead to differences in child neurodevelopmental and mental health. But to do that, I kind of came to my second lesson, which is that teamwork really makes the dream work. It turns out that if you want to do this kind of work and you really want to do it in very large samples that are diverse and reflect the experiences of all children in the United States, it is nearly impossible to do it alone. And so this was my time of my career of increasingly large team science collaborations. The first one you see here, this is the CANDLE study. It's a pregnancy cohort of 1,500 mother-child dyads, started in 2006. The kids are now teenagers or getting harder and harder to study every year. It is very socioeconomically and racially diverse. It really represents Memphis quite well, which is where it's where it is. And in this study, we were broadly focused on understanding the early life predictors of child neurodevelopment and mental health outcomes. And so in 2016, we joined forces with 3 leaders in the chemical exposure and air pollution area to form Pathways, which combined CANDLE with 2 other cohorts for a total of 7 study sites, which you can see here in this map. This is a study of about 3,000 kids where we looked at the impact of chemical exposures, air pollution, and social stressors on neurodevelopment, as well as asthma. You can see our team here. The teams are getting bigger. And then this study was actually also part of the environmental influences on child health outcomes for the ECHO cohort. And you can see here the group of PIs that were at the first meeting. There are actually about 1,500 investigators involved in this project across the nation. And it has been a really exciting project to be a part of. So I'm going to just talk a little bit more about that. So this was the design of ECHO. It was designed to basically develop an omnibus cohort of children and their families to understand a variety of health outcomes, which you see down here. Neurodevelopment is one of them, but also pre-peri postnatal outcomes, asthma and airway health, obesity, and positive health. And so this study actually brought together 75 individual cohorts, harmonized a bunch of extant data, got some new data, and has really created this very large national resource for folks to understand child health. There are about 60,000 participants from cycle 1. Cycle 2 just started, and we already have about 21,000 participants. And it's a very massive effort, over $1 billion from Congress so far to fund this. And I've been very fortunate that right now I'm on the steering committee for this consortium, and so it has been really rewarding to, even if slowly, kind of navigate this tanker of a cohort study and kind of see how it has been growing and evolving. So given that it is such a wonderful research, I did want to highlight just a couple things that we've done with this cohort. So because we had everybody collecting data using the same protocol, we were actually able to rapidly mobilize and capture quite a bit of the COVID-19 pandemic impact. And so we sent out a survey to folks that didn't just capture infection, but also captured all of the social changes that happened. School closures, remote learning, financial instability, social distancing, and then also concerns about access to supplies and resources. We were actually able to get about 15,000 families to participate, which, you may remember that like most of science kind of stopped during this time. So this was actually kind of a really great insight into kind of what was happening in the lives of children and families. And so in one study, we basically wanted to know what the greatest sources of stress from the COVID-19 outbreak were, but also whether there were differences in those sources of stress. So this is what we found overall. Folks were very worried about social distancing, impact on family, health concerns. Kind of lower down on the list were things like access to supplies and access to food. And maybe this resonates with you. Maybe this is kind of what you would have thought were the most stressful things about the pandemic. But when we looked at differences by caregiver education, we actually found some really striking differences. And so first, just highlighting these three, access to food, supplies, and financial concerns, we see a very clear gradient with caregivers, with caregiver education, such that lower levels of education folks with lower levels of education are much more concerned about these issues. And then it actually flips for other issues, things like social distancing, impacts on the child and the community, and health concerns. And also from this paper, we found that caregivers with lower levels of education were much less likely to be able to work from home, and also had much less flexibility when it came to changing their childcare circumstances or kind of accommodating childcare needs. And so collectively, our findings suggested that one's ability to respond to and cope with the changing needs of the pandemic and all the disruptions were really strongly patterned by caregiver education, and it highlighted the sometimes really extreme socioeconomic differences in the impact of the pandemic on children and families. And so that brings me to my next lesson, which is one size may not fit all. And so even though we saw very big differences in pandemic-related experiences, we were also wondering whether this mattered for child outcomes, so child mental health outcomes in particular. And so we used this same cohort to look at actually leverage some of the longitudinal data we had, which was very unique during the pandemic. So we had measures of pre-pandemic mental health and during pandemic mental health, and we were basically able to ask, what changes did occur during the pandemic. A lot of the work was cross-sectional, and so this was something that we did in the ECHO cohort. And so we both looked at changes overall, but also whether the changes differed at all by subgroups. And so kind of surprisingly, we found that on average, there were pretty small changes in mental health outcomes among kids in our study. And we also found evidence that one size doesn't fit all. We saw actually improvements in kids with pre-pandemic problems, particularly those with externalizing behaviors. So having a lot of problems paying attention and sitting still and kind of sitting in a classroom. We also saw small improvements among racially minoritized children and children with lower SES. And so we kind of took away from this that potentially schools are stressful environments for some kids. If you're coming into school with mental health problems that make it hard for you to sit still, school may be kind of stressful. If you're coming into school and it's maybe not a safe place for you or you face discrimination, maybe that's not great for your mental health. So certainly, the pandemic had really horrible impacts on academic achievement and certainly widened racial and socioeconomic disparities, and is the subject of a lot of recovery efforts that are very, very important. But this kind of additional look at mental health kind of gives us some insights into kind of other ways that we might think about influencing mental health and kind of the role of schools. And I just want to give you one other example of this one-size-fits-all idea, and this is collaborative work with our colleagues at the University of Washington, who added really high-quality air pollution data to our candle sample. And we looked at the association between air pollution exposure during pregnancy and child cognitive performance. And so importantly, air pollution exposure is not equitable, even though it comes from a variety of sources. We still see social disparities in air pollution exposure. You can see on the left low-income zip codes, and on the right higher-income zip codes, and a lot more air pollution exposure on the left. And so in this study, we were interested in both whether air pollution exposure during pregnancy had a main association with child cognitive performance at age 4 to 6, but also whether we could identify any buffers or things that might protect against any negative effects we might see. And so we looked at maternal nutrition. We looked at two aspects of maternal nutrition, both dietary recall nutrition and then also a plasma measure of folate levels, so using biomarkers that we had collected in pregnancy to look at that. And so what we found was that overall exposure to PM10, which kind of is a larger particulate matter of air pollution, was associated with a little bit of a reduction in IQ, that you can see that highlighted there. But what was really interesting is when we looked at the impact of maternal nutrition, we didn't see anything for maternal reported dietary intake. But when we looked at the plasma folate levels, we actually saw that that entire negative relationship we saw in the whole population was actually driven by folks who were folate deficient or in the first quartile of folate, plasma folate. And so among those folks, the IQ association was more like 6 points less, which is actually quite large. And we also noticed that there were very significant disparities in levels of plasma folate by socioeconomic status and race, and that's true nationwide. So here, we found this, we demonstrated again this notion that one size might not fit all, but we also identified something modifiable, folate supplementation, that might really mitigate these negative impacts that we see of air pollution on cognitive development. And even though folate is a recommended dietary supplement, about 20% of pregnant people are folate deficient during pregnancy. So this is a real opportunity to improve child outcomes and address disparities. And that brings me to my last lesson, which is that public policies really do make a difference. So we were able to look at the Special Supplemental Nutrition Program for Women, Infants, and Children, more colloquially known as WIC, and its relationship to maternal nutrition during pregnancy and child outcomes. So WIC is a very large, one of the largest safety net programs in the US. It serves about half of all infants. In 2009, WIC improved their nutrition package. So it increased whole grains and fruits and vegetables and low-fat milk. So basically just kind of gave it a reboot. And in Candle, that policy happened to act as a natural experiment. Basically, half of the moms were pregnant prior to 2009 and half were pregnant after. And so we were able to leverage that difference to basically compare both maternal nutritional outcomes and child outcomes before and after the changes to the nutritional package. We use this really robust design from economics. This is a difference in difference model. It actually allows us to kind of treat the policy change in 2009 a bit like a random experiment. And so it provides quite strong evidence for how socially patterned safety net policies may be able to alleviate disparities. And so when we looked at the impact of this policy change, we found that it did improve maternal nutrition during pregnancy, but it also had an impact on the offspring. So it also improved cognitive performance at age 2, and this was actually a pretty large effect that had clinical significance. And so we kind of found that improving these large social safety net programs really are one pathway to reducing disparities in child neurodevelopmental outcomes. So just to summarize, who participates in research really matters. The first study I shared demonstrated that even for basic questions like what is the association between age and brain structure, we really won't be able to make good inferences to people who are not included in research. And I think this is a really important piece, especially if we're going to be dealing with inequities in child experience and disparities in child neurodevelopment and mental health outcomes. Teamwork is really important. I talked a lot about some of the challenges facing behavioral sciences in general, including the replication crisis. And to me, I really do think that the future is interdisciplinary and collaborative, and it will require strong teams to get the work done. I really love this image from the Robert Wood Johnson Foundation that highlights the differences between equality and equity. So if we aim for equality, then we would give everyone the same bike in this image, right? It doesn't matter if that bike doesn't fit you. It doesn't matter if you can't use that bike. That is what it means to aim for equality. If we aim for equity, it actually focuses on this notion of one size does not fit all. And so, that means that we might be considering individual differences or subgroup differences and thinking about the different supports that children need to thrive. And so evidence that I shared related to some of these individual differences are actually great places to look for what we might do here and how we might improve health equity. And then I just wanted to end with this idea that if we really, I just wanted to end with this idea that we can really improve child outcomes and reduce disparities by shaping public policies to be more child and family friendly. These policies, like reducing air pollution exposure or improving early nutritional and educational environments, these have the potential to actually shift the distribution for all children towards better outcomes, not only impacting children and their families, but also the parents those children may become. And so I just want to end with some acknowledgements. This is summarizing a lot of team science work. This does not even include everyone, but I certainly want to thank the families and children who have participated in all of these studies and all of my colleagues. And then I also want to share some gratitude for two Trinity alums, the class of '62. This is my dad on the left and his best friend Dave on the right, two gentlemen who have been very influential in my career. Thank you so much for this honor again.
Thank you, Dr. Lewin. We really are just so delighted to have you here. My name is Laura Holt, and I am a fellow alumna and professor of psychology here at Trinity. And Dr. Lewin has graciously agreed to take some questions. So if you'd like to ask a question, I'll ask you to please raise your hand, and we will bring you a mic. We're live streaming, so it's very important that you wait for the mic so that we can make sure that we hear you and that folks who are joining us virtually can hear you as well. So with that, I'd like to open the floor for some questions. Yes, sure. Jackie Santiago from Compass, welcome.
Hello, everyone. Hello, everyone. Jackie Santiago from Compass Youth Collaborative, also Trinity class of 2000. Yes. So this is a topic that is near and dear to my heart. I work as the CEO at Compass Youth Collaborative, where we work with youth that have been impacted by violence specifically. And we know that the development due to trauma is much different than the normal development. Can you tell us some of the things that you found that are that might be interesting to our work, and when we think about youth violence in this environment and what the impact it has on them?
Mm-hmm. Yeah, I mean, that's a great point. And unfortunately, many youth are exposed to violence, right, in our country. And it does have profound impacts on brain development and then also behavior. I think that some of the best work really is around trauma-informed care and also ways of kind of informing folks what it is, like what someone who's experienced violence and maybe is carrying some of the behavioral and kind of and like underlying, right, physiology that goes with some of those behavioral challenges, that's actually coming from a place of trauma, right? It's a stress response. And so I think a lot of the most important work has actually been around kind of informing folks that is not a child, being bad or being difficult. Like, that is somebody who is trying to regulate as best they can in a circumstance that is actually really hard for them to regulate in. And so I think, we do have work looking at, sort of early adversity and other exposures. I don't directly study exposure to violence, but I do feel like I think the answer for youth in particular is really just understanding and patience, like that they have been through a lot, and so kind of expecting them to come to certain environments and kind of be perfectly ready to do something, is we need to kind of expand our idea of that and then learn how to support them in the way that they need to be supported.
We have
let's see, we have a question. So right here in the middle. And we'll pass the mic down to you.
Hello, Dr. Lewin. Thank you very much for your time and your lecture. I found it very interesting. So I wanted to ask you something about what you were saying, the neuronal development in people from minorities and I would say lower socioeconomic status here in the United States. And you're also talking about how certain public policies after 2009, I mean, this is maybe related to the ACA back in the day, like supported these communities, and helped them improve their neuronal development. What other things do you think we could do to support, these underrepresented, marginalized communities, because I also appreciate you sharing, that it goes beyond, for example, racial marginalization. It's actually biological, the fact that these communities are poor, it's affecting their genetics, So what else do you think we could do, to address these very important issues?
Yeah, I think, I think the thing that, so if I had my dream, I feel like, what we really need is something like, consistent and connected care and interventions that start with conception. I mean, ideally, right, you kind of want to imagine the history where you've already done all these things, right? But if we start with conception, there's a lot of things that can be done during pregnancy. And then there's actually some really successful supportive programs, even in very early development, right? There's a lot of home nursing programs that help folks, kind of learn more about, early childhood development and how to support early child development, the importance of language exposure and all of these things that kind of set folks up for their schooling experience. But I think the main thing is really, I think we need to just improve our educational environments. There are massive disparities in educational experiences. I think I mentioned the early development piece because that's actually really important too. It starts very early, so you need to do something there as well. But to me, it's really a social injustice that we have such disparate early education environments. And it's just very hard to catch up, right? Because of the way the brain develops, like things are the most plastic early on. And so you can catch up and you can do wonderful things, but that's just really stacking the deck, right? And so I think for me, it's really improving the educational system. I know that's kind of simple, but I really think we need to do it.
See, we have a question all the way in the back, over on my right, your left.
My name is Elsie Sachs. I'm a first year here at Trinity College. And you talk about cognitive development starting at pregnancy, and what happens in pregnancy can affect the IQ of a child's life and therefore their eventual socioeconomic status. And I was wondering if, in terms of mental health, if there's a proportional relationship between IQ and mental health, and if you've done research on that and how that affects a child's life.
Yeah, so we have done work actually looking at the relationship between cognitive performance in childhood and then eventual mental health outcomes, and there is an association there. It's not, so strong. It's not a direct, relationship, but I guess I would say we definitely see similar kind of intergenerational and also intergenerational, meaning starting in pregnancy and also things that moms have experienced impacting children, the next generation in terms of mental health. So that's actually a lot of work that's been led by my colleague in the Candle study. She focuses a lot on pregnancy exposure to stress and then also maternal stressors during childhood. And both of those things seem to independently predict behaviors in childhood. And so there is basically a good amount of evidence, I would say, across mental health and cognitive outcomes that basically our experiences kind of early on really seem to matter. I don't want to give folks the impression that there's no changing after that at all, right? So there's actually a lot of room for flexibility. I think my point is really just my goal is to do work that helps children get off on the right foot, right? So it's not that we can't make life-changing decisions or interventions or change our behaviors well into adulthood. It's just that it just gets harder to do all of that, right? And the other piece is that some of these exposures and inequities are socially unjust, and so we should deal with those, right? But there's a lot of flexibility in human development, and it kind of continues, so that's definitely an important message, yeah. Yeah. Oh, sorry, I'm not picking.
Thank you so much for being here. My name is Ava Cottle. I'm a senior, and I'm in the public policy department, which meant that I was particularly fascinated by your discussion of policies and safety nets. In particular, I know that programs like WIC, although they're standardized, can sometimes come at odds or collaborate on a continuing spectrum with community programs and care centers that can sometimes target the needs of a community more directly. So I was wondering if your research cohort, in addition to standardized programs like WIC, also considered the potential impact or worked with community organizations to assess the impacts on mental health in larger communities.
That's a really wonderful question, and it's a good point to bring up that there are lots of things going on in communities that can be supportive, and actually it really varies. Jacob mentioned my work with the Flint folks, and they're actually almost like a countless number of interventions happening there, right? And so it can actually be very hard to tease things like that apart. And I think this is actually one of the challenges that we do have kind of in evaluating certain things, and that's why kind of this WIC example with the kind of randomization from the 2009 change was really unique, because otherwise, at least in Candle, we would not be able to disentangle all of those different influences that you are talking about. So I can't speak to how they interact in our particular cohort, but I think that's a great place for large administrative databases, that actually cover hundreds of thousands of people. And I do work with folks who, kind of look at things like, the earned income tax credit and other things that kind of support families that have a big impact on development. So great question, thank you. You see him, okay.
Hi. I was really interested in the, to point one where you were kind of, I think it was point one, where you're kind of getting into that, depending on whether you're weighted or unweighted, and you did the analysis, it seemed like the trajectory really shifted pretty dramatically. And I would imagine then that means the groups that were getting weighted were really had a different trajectory pattern compared to the ones who would traditionally be more heavily weighted in an unweighted sample. Did you look at that group more specifically and identify specific features within that might have contributed to that shift? And then would you imagine that shift was actually meaningful for important developmental outcomes for those individuals?
Yeah, so you really paid attention to that study. I'm super impressed. So yes, everything you said. So basically, so the weighted model basically showed developmental trajectories earlier, right? And the weighted model was weighting folks with lower resources and in those lower income, right, more adverse circumstances. And so that does kind of track with adversity and brain development, where things kind of rush along, and particularly subcortical, regions. And so that was kind of how we understood that, but we didn't really have the capacity to do more than that, than just to say, here was the pattern we saw. This does make sense given the fact that we do tend to see kind of trajectories being a little advanced if things, if circumstances are more adverse. And so, but that was a great point, yeah, and that's exactly how we interpreted the information. Thank you. Thanks for listening so well.
I think we have time for one more question, so just want to make sure if anyone else has something they'd like to ask Dr. Lewin. Going once, going twice. All right, well, thank you very much for your questions.
Thank you. That's good. Okay. Hi.
That was amazing.
Oh, thank you.
That was really great.
Good to see you too.
All right, so, you can't really see up here.
Yes.
Oh, no, it's the light, but I'm all right. So I'm really thrilled that Kaya Lewin was selected for this award, and I'm happy that this evening has become, in part, a celebration of women in STEM. You might have noticed the slideshow that was up before, and it'll be up again to point out the women in STEM doing work at Trinity. You'll also notice posters around the room of all the different STEM faculty and the work that they're doing and work with their students. So during the cocktail hour, I strongly suggest that you go around and take a look at all of the great science that's going on. I think this is amazing to have a celebration of women in STEM in the last year of having a president and Dr. Lewin, who are both trailblazing neuroscientists. And Kaya's been a trailblazer for a long time. I was still relatively new to Trinity when I started teaching, and she took my large sophomore class and was kind of quiet compared to other people, so I didn't get to know her so well. But by the time the next semester, she had taken 2 seminar classes with me. I knew that she was someone that I wanted to invite to work to do research in my lab. I said to her earlier today that she was one of these students who is just infectious with intellectual curiosity. It was like her brain was on fire all the time.
Was on fire.
And she took advantage with that mind of everything that Trinity has to offer. In fact, her senior spring, no pressure on the students in the room, her senior spring she took feminist thought, Buddhist thought, South Asian history, and a senior honors thesis in neuroscience. So she was having it all. In fact, I have her senior thesis. If anybody would like to look at it, you can do the next. So that was Kaya, and that's her thesis.
Oh my gosh, that's so funny.
It's also in the Watkinson Library because she's one of the students who paid attention and deposited it in the Watkinson Library, as we asked them to do. In my lab, she was working with people who have brain injury, doing cognitive rehabilitation, and the easy route for her would have been to do her senior thesis on that work. She'd been doing it for a couple of years already. But that wasn't Kaya. At the time, I was facilitating a support group for women who had survived domestic violence at the Interval House, and Kaya was also volunteering. And so she decided, let's do a study on brain injury and domestic violence. Nobody had done this, by the way. And so she got excited about doing this and took on such a big project. I was looking through her thesis the other night, and I was like, how did you do that as a senior in neuroscience? She compared women who survived domestic violence with brain injuries to those who had not. She then compared them to a group who had had a brain injury but not experienced domestic violence, and then to a control group who hadn't experienced any of those things. She compared their attention, memory, post-traumatic stress disorder, and measured their cortisol levels. I look back at this now, and I am so amazed that this is what she did. And by the way, in her reference list of 50 references, there's not a single one that was doing the work that she was doing. This is such groundbreaking work that, in fact, last year, my lab, sort of weirdly coincidentally, or maybe we were sort of harking back to Kaya's brilliance, published a paper on exactly this topic. And it was the first paper that we could find published using neuropsychological measures in this population. So 30 years later, we published the first paper on something that Kaya did back when she was a senior here. To say that she was ahead of her time is quite an understatement. As a Trinity undergrad, she was already putting together questions and seeking answers that combine lines of thought that are traditionally disparate in ways that give data that actually make lives better. And so I'd like to invite President Berger-Sweeney, who is the president and Trinity College professor of neuroscience. President Berger-Sweeney is, of course, herself a trailblazer who became the first African-American president and the first woman to serve as president at Trinity College.
Thank you, Sarah. Thank you, Sarah. That was incredibly generous and sweet.
So my first question for you, and I'm very sensitive, would you like us to bring up a chair? Because you've been standing for a long time.
Oh, that's so kind. I'm all right.
You're okay?
I got adrenaline
Okay.
coursing through my veins.
Excellent. Okay. So I do have some prepared remarks, but before I start those, I want to share with you as you were going through your talk, if there was a Venn diagram of overlap of our lives and careers, there would have been a lot. From losing a parent as an undergraduate, through epidemiology, behavioral science, I was therefore not surprised that I chose you as receiving the President's Medal. There was just a lot to resonate. And the second thing that I want to say is really on behalf of Sarah Raskin. So if you graduated in 1998, you could have been one of my students if I was teaching at Wellesley at the time in the neuroscience or psychobiology, then neuroscience program. But when you are a faculty member and one of your former students grows up like you do to do the incredible kind of work, the satisfaction is almost like a parent. Sorry, Maya, I know she has a real parent. But when you are a faculty member and get to work with students who then go on and do incredible work after they leave, it's a satisfaction that I'm sure all resonates with every single professor that's here. As I said just last week, it's okay if every one of my students is smarter than I am. That can be very satisfying and humbling too. So thank you very much for being here. So now I'll go to a bit more my prepared remarks. Thank you, Sarah, for the kind introduction. And Kaya, thank you for a really terrific lecture. It was really fascinating. Since our founding in 1823, Trinity College has been proud of its commitment to the study of science, technology, engineering, and mathematics, STEM, in a liberal arts context. We are unusual for having a small, I say but mighty, engineering department embedded in the liberal arts tradition. As a scientist myself, I know how integral scientific, evidence-based thinking about the natural world is to a broad, balanced liberal arts education. For centuries, Trinity has been a place for problem solvers and innovators, answering questions that no one has asked and creating solutions to problems. In the 1960s, Dr. Vernon Crable, a Trinity professor of chemistry, and his son Bob solved a problem that previous chemists had not been able to solve. They created a liquid adhesive that could bind together substances with incredible strength, a superglue. They also created a chemical company using trained engineers as salespeople to convince other engineers of the value of their superglue. This was a scientist, innovator, and entrepreneur right here at Little Trinity. As another sign of educational innovation, Trinity College has one of the first undergraduate neuroscience programs in the country, founded in the 1990s. Today, virtually every self-respecting liberal arts college has a neuroscience program, but not then. 3 years ago, I recognized that despite Trinity's strength in the STEM fields, there was not a single endowed annual lecture at Trinity College in STEM. That just seemed wrong. So I asked an advisory committee made up of faculty and staff members to help me design and enact an appropriate way to recognize scientists and innovators at Trinity. And so, the President's Medal for Science and Innovation was created. The award recognizes a prominent, internationally renowned individual in science, technology, engineering, or mathematics who has influenced STEM with market success and who represents the liberal arts ideal of empowering humanity through the sciences. It fills me with joy, admiration, and pride to share that the recipient of the 2024-25 President's Medal for Science and Innovation is Dr. Kaya Lewin, Trinity Class of 1998. Kaya, for your pioneering work as a research psychiatrist and educator, and for your advocacy for equitable and accessible mental health care for all, it is my distinct honor to present you the Trinity College President's Medal for Science and Innovation. Through your scholarly contributions and research, you have profoundly influenced urban planning, educational policy, and preventative mental health strategies, areas that shape society's foundation. As a professor of psychiatry and behavioral science at the University of California, you have become an esteemed leader in behavioral science. Since graduating from Trinity College and earning your doctorate of science from Harvard University, you have built an influential career at the intersection of psychiatry, psychology, public health, epidemiology. Your research employs rigorous epidemiological studies, sophisticated statistical modeling to identify the social determinants of mental health disparities, with a particular focus on early life adversity and its lasting impact. Your work provides vital evidence supporting policies aimed at reducing societal disparities that harm mental health, and your findings, regularly published in premier medical and public health journals, make essential contributions to both academia and public policy. Your research is particularly noted for its investigation into how socio-environmental factors, also socioeconomic, but environmental factors such as neighborhood characteristics, community resources, and systemic inequities influence neurodevelopment and emotional outcomes. Your contributions have advanced our understanding of the mechanisms by which environmental stressors can shape cognitive and emotional development, thereby offering invaluable insights into the development of mental health disparities. Your findings underscore the critical need for structural change to alleviate social inequities that negatively impact mental health, with policy implications that extend to urban planning, educational frameworks, and preventative health strategies. As a highly regarded member of the academic and research communities, Kaya, your work has garnered recognition for its potential to inform transformative public health policies aimed at reducing mental health inequities. Your scholarship, regularly published in premier academic journals, highlights the profound impact of interdisciplinary research in addressing complex health challenges. Through your dedication and expertise, you exemplify the commitment to knowledge and public service that Trinity College strives to inspire in all of its graduates. embodying the ideals of scientific inquiry and social responsibility that contribute to the betterment of society. For leading a life of innovation and impact, and then inspiring the next generation to engage with the often difficult questions of our time, it is my profound honor to present you with the Trinity College President's Medal for Science and Innovation. Okay, the question is, even with my step,
I can do
I
a
think
little
so.
bit of this. Thank you.
All right. Please join me in congratulating Kaya Luen.
Thank you.
And thank you, Kaya, for joining us here on campus tonight. You are most deserving of this recognition and an impressive ambassador for what this medal embodies for the future. Now, this concludes the formal portion of the ceremony. Now I invite you to the reception in honor of Dr. Lewen's achievements, and we are so, so proud of you. Thank you for coming.
Oh, thank you so much. Thank you.